2-point sources of sound are kept at a separation of 10 centimeter. They vibrate in phase to produce waves of wavelength 5 centimeter. What would be the phase difference between the two waves arriving at a point 20 centimeter from one source? In the A, it is given that if this point, that is 20 centimeter from one source, is on the line joining the sources, and in the B part, this point is on the perpendicular bisector. Fine. So let's draw the diagram first for the A part. That let's say these are my two sources A and B. They both produce sound waves, and I have to calculate the phase difference at a point that is 20 centimeter from the one source. Let's say this distance is 20 centimeter, and they are on the line joining. Fine. So this is the case, and the distance between A and B is given as 10 centimeter. Fine. Now we know that phase difference is given by 2 pi by lambda into part difference. That is, I have to calculate the part difference which is occurring at point C due to A and B. So I can write 2 pi by lambda. Part difference will be equal to AC minus BC, right? So it will be equal to 2 pi by lambda. AC is given by 20 plus 10 centimeters. So divided by 100 to convert it into meter, minus BC, that is 20 again. So the part difference comes out to be 10. So it will be 2 pi by lambda. Lambda is given as 5 centimeter. And here it is 10 centimeter, of course. So the phase difference comes out to be 4 pi. Now if the phase difference is 4 pi, then what does it mean? This is how I plot the phasor diagram, that the particle goes into revolution. When it completes a phase of 2 pi, it reaches the same point. Similarly, if it completes another 2 pi, that is, if it completes the phase of 4 pi, then the particle is at the same point. So what does it mean? It means that if the phase difference is 4 pi, then the particle are in the same phase, or you can say the phase difference is 0, right? So the phase difference will be 0. That is my answer for the first part. Similarly, for the second part, if the point C lies on the perpendicular bisector of AB, right? Let's say this is my point C, and this distance is 20 centimeter. Now in this case, again, change in phase or the phase difference will be given by 2 pi by lambda into part difference. Now part difference will be given by AC minus BC, as I wrote over here. Now as the point C is on the perpendicular bisector, so what does it mean? It means AC is equal to BC. So automatically phase difference comes out to be 0. The answer.